Saxon Advanced Algebra? No, that's not the name of this course. Saxon Advanced Mathematics. Tricked me, John. Lesson 41. There's actually two parts to this lesson. We're going to talk about reciprocal trig functions first, and then we're going to change gears and talk about permutations a little bit. So there's just a little splash at the end of permutations. Mostly we're going to talk about this. Now, I want to remind you about two words that often get confused. Inverse versus reciprocal. Sounds like a movie. Man versus Alien. Wasn't there a movie like that not too long ago? You guys were probably like in diapers then. Whatever. Hang on, let my brain catch up with my hand. Or vice versa. Reciprocals. Okay. Inverse are the trickier of the two. The inverse functions are the thing where if we take an input A and we put it into function, we'll call it F, then we get out an output called B. And then if we take whatever B is and we put it into function G, let's say, and we get out A, then we would say that these two are inverse functions. They kind of undo each other, right? Function F takes A and turns it into B. Function G takes B and turns it into A. That's more complicated. That's where we have to solve for X and then flip all the letters around, right? It's complicated and it's messy, and we're not talking about that. We're talking about reciprocal functions, which are literally just upside down. Okay? They're fairly straightforward, and up until now I'm just going to talk about reciprocals. That's our topic for today, not inverse. I just wanted you to see the difference. I'm going to now expand on how reciprocals look. Okay, reciprocals, we learned a long time ago that if you just make up a reciprocal, let's call it x over y, that to create the reciprocal of that, you flip it. Okay, so this is the flip it mentality. That works. But in the work that we're going to be doing with these trig functions, sometimes it's helpful to look at the reciprocal function in a different way. In this one, we still start with x over y, but we're going to put that over 1. This is called the 1 over mentality. These are my words, by the way, not John's. Can you tell? Because we take the fraction and we put 1 over that fraction, okay? So this is flipping it. This is the 1 over. What I'm going to show you is that they yield the same result, because let's pretend, well, we don't really have to pretend it's a complex fraction, because it is, but we're going to simplify this like we would any complex fraction. We're going to multiply it by its reciprocal to get it to turn into a 1, but what we do to the bottom, we have to do to the top. So our final answer, this poofs and goes away, and our final answer becomes y over x. And look, that's exactly what we wanted, right? So we can think of creating reciprocals in either one of these two methods. I'll just let that be in the box too, right? Either we flip it or we take 1 over the original fraction, and that's another way to create the reciprocal. This is just to get your head around what you already know about reciprocals and to remind you that reciprocals really are the easy ones. You just flip things. Inverse are the weird ones where you're going like inside out. A lot of students muddle those in their brains, understandably so. Okay, so now we've reminded ourselves of trig functions, or of reciprocal functions. Now let's go back and refresh what we know about our basic trig functions. Well, we know there's sine, cosine, and tangent. We've been through this, right? And we know Oscar had a hold over Arthur. Those functions we have used, we love them. We're now going to refer to them as the parent functions. Not always, but sometimes, because they're like the originals, right? I guess we should call them the Adam and Eve functions. I don't know. But in any case, we're going to use those and we're going to learn to develop reciprocal functions. So we know two ways to find the reciprocal of something, right? One is to put it over a 1. The other way is to flip it, okay? That's going to be the first reciprocal function we talk about. Let's do the rest of them. 1 over a over h, or that, right? I'm showing both ways of making them. This is the 1 over method. This is the flip it method, or mentality, I guess I was calling it. 1 over o over a, which, and let me make my lines just a little bigger so you can tell clearly which are the big lines. And then this one would be OA, okay? So these are what we call our reciprocal trig functions. Now, here's the reciprocal of sine, here's the reciprocal of cosine, here's the reciprocal of tangent. We can tell because we see it's the very same pairs, right? OH, HO. It's the same pairs, just flipped upside down. It's easy to see this reciprocal and trace it back to its original. It's easy to take the original and find the reciprocal, right? And we can use either of these two forms, whichever is going to work out better in our problem, right? It's totally up to us. Now, here's the part where it gets a little tricky. It's not really tricky, but it blows people's minds. This all goes down really smooth. Now I'm going to tell you we have new names for these suckers. We don't just call this reciprocal of sine, reciprocal of cosine, reciprocal of tangent. Oh no, that would be too easy, and every student wouldn't necessarily be confused. So we can't have that. We need a new word to freak everybody out. This one, ready, is called cosecant. And this one is called secant. And the last one is called cotangent. And these have abbreviations to CSC, cosecant. Secant is SEC. And cotangent is COT. So just like we abbreviate these, we abbreviate these. Now, how do you keep them straight? This is really confusing because don't you want cosine and cosecant to go together? But they don't. So frustrating. And even secant and sine seem like they should sort of be friends, but they don't go together. Here's how I remember. See how there's a C here and an S here, and then an S here, and then a C here? They don't match up, okay? That's the tip. That's the tip. That's the trick. Don't let the letters match. S goes with C, C goes with S, okay? And you kind of have to override your intuitions, which tell you that the two co's should go together. But like, look at tangent goes with cotangent. It's perfect, right? Why can't they all be so easy? But they aren't, and later we'll find out why, which is kind of fun. But here's the thing. Knowing these ratios and knowing the abbreviations, we can work trig problems that give us the angles as reciprocals rather than just like this. So let's take a look at how these work. It's just, you know how we've been taking these problems where you draw the pictures and we've just been making them one step harder, one step harder? Well, it's just one step harder. Example 41.1. Ready? How many are there of these? I like to tell you ahead of time so you can like strap in accordingly. There are 4 of these triangle problems, and then we switch to permutations, and there are 2 of those. And it kind of fits together into one big one. Okay, draw the appropriate triangles and evaluate. We need the secant of 330 degrees plus the cotangent of 480 degrees. Okay, so we go one by one. We logic our way through it just like we have been. Secant of 330. Okay, 90, 180, 270. That means I'm going to be here. Another way I can look at this is I'm in the fourth quadrant and I'm 30 short of going the whole way, right? Because the whole way would be 360. So this is 30 degrees. Now it's my reference triangle, so I have to think about that for a second. This is 2, this is 1, this is square root of 3. Now I want the secant. Secant, I'm going to try and remember without looking at this side. Secant is the opposite of cosine, so secant should be h over a. Secant is h over a. Notice it says ho, ha, and ao. Kind of. I don't memorize them that way, but that just kind of sticks in my head. Okay, so this is going to be ha, which is equal to hypotenuse 2 over adjacent, which is square root of 3. This is secant. And a nice thing about the trig signs is they have the same plus or minus sign as their corresponding parent. So let's draw that chart right here. This is the week that I'm going to teach you about the unit circle, and we won't have to draw these little pictures anymore. Aw, won't you miss them? Okay, so secant in the fourth quadrant is going to be the same as cosine in the fourth quadrant. Cosine in the fourth quadrant is positive. Okay, so I'm just going to put a big plus sign there so I'll remember that I checked. Okay, so there it is. Should I rationalize it? No, I'm going to wait till later and see if I need to rationalize it. Okay, cotangent of 480. Okay, this number is larger than 360. So I'm going to subtract 360 out. So it's 120 degrees that I'm trying to find the cotangent of. That's going to be in the second quadrant. So I'm going to be like this. 90, and then I need 30 more, so I'll have 60 left. So it'll be like this. Oh, now I drew that in a confusing way. So this is going to be 2, and this is going to be 1, and this is going to be square root of 3. Okay, my 60 triangles tend to get off, and then it's harder to tell which side is which, but that's right. Cotangent is the opposite of tangent. Tangent is over Arthur, so it's AO. Cotangent equals A over O, which equals, see, we're right here. So adjacent is 1 over opposite, square root of 3. Cotangent is going to be the same sign as tangent in the second quarter. And in the second quarter, tangent is negative. So this is minus. I'm going to put it up high. So now I can bring my two pieces together. 2 square root of 3 minus 1 square root of 3 equals 1 over square root of 3. I can do that even before I rationalize because the denominators match. They aren't rationalized, but they match, so I can still operate upon them, if you will. But now for my final answer, I'm going to rationalize this little doggy. And my final answer is square root of 3 over 3. There's my minus sign that came because cotangent and tangent are negative in the second quarter. That's where that minus sign came from, right? So these signs for the reciprocal functions are the same as these. This is the right answer. Pretty happy about that. Okay, let's do another one. All right, make sure if you didn't, make sure these are in your notes, but make sure these go into your special place. If you didn't already do it, pause me now, write it down, and then come back. Okay, you're back. Let's do 41.2. Ready? Draw the appropriate triangles and evaluate. 2/3 times the cosecant of minus 3 pi over 4. Well, here we go. John's gonna trip us up by throwing in some radians, but we can deal with it. It's not a big deal, right? Minus the secant of 11 pi over 4. Okay, so, boy, we have a lot of information we need, don't we? Let's start by remembering our reciprocal functions. Cosecant, secant, and cotangent. It goes ho, ha, ao. If someone would like to make me up a nice story about Oscar and Arthur and how their fight is progressing that uses these letters, I would love it. Okay, so there's that. We need our plus minus signs for the 3 quadrants. And then something else I know that we're going to need is remembering that pi equals 180 degrees. And I'd also like to take that pi over 4 is 45 degrees, right? Because that's going to help us with these fractions. Okay, so let's fix that first. Let's get rid of the radians and be done with it. For this one, the pi over 4 reduces to 45, so I need 45 times 3, 12. So this is minus 135 degrees. Okay, all the rest is the same, so I'll just copy it. All right, and then this is minus because that's the problem. And then secant, and then again, this much is 45, just like it was here. So now I have to do 45 times 11 is going to be, let's see, you just write 45 twice, right? And stagger it. 495, but now we can subtract 360 from that, because that's got an extra spin in it, right? Spin in it. 135. Okay, so this is secant. I'm just going to draw lines in that so it doesn't confuse me. 135 degrees. All right, so for this one, I'm measuring backwards. It's going to be in the 3rd quadrant. Going from here to here, that's going to take up 90, and then I need 45 more, so this one goes right down the middle. 1, square root of 2. There's our 45 degrees. And then this is positive 135. So this is going to be in the 2nd quadrant, right? Because I'll have 90. And then again, I'll want half of this to be in here, because that means 45 is here, plus the 90 is the 135. I hope that makes sense. I just talk until I'm tired of listening to myself, and then I stop. That's not really true. But it's a weird feeling to be explaining something to people that you can't see their faces. So I have no idea if you have like fallen asleep because you got it 5 minutes ago, or if you're like ripping all your hair out and jumping up and down on your desk because you don't know what in the heck I'm talking about. So, I'm just looking for that happy middle, shooting for the sweet spot. Okay, cosecant. It's going to be 2/3. Remember this number we're multiplying on the outside, it doesn't really change the battle plan for this problem. It just means get this answer and then multiply it by 2/3. Cosecant is the opposite of sine, so it's going to be the ho, and that's right. So that's going to be, let's see, I'm just going to write this. Cosecant equals ho. So I'm going to put the hypotenuse up on top, and I'm going to put the opposite side on the bottom. All right? So that's the 2/3 that's just chilling. The cosecant of minus 135. Cosecant is ho. hypotenuse over opposite, and that's that. All right? Then we're going to subtract, and this is secant. So I'm just going to jot secant equals ha, right? Okay. Oh, I need to find out if this is positive or negative. It's cosecant, which is the opposite of sine. It's in the third quadrant, so it's minus. You with me? Okay. This minus sign is just in the problem. Now, the secant of 135, secant is ha, so it's the hypotenuse, square root of 2, over the adjacent, which is 1. Now, what about secant goes with cosine in the second quadrant is negative. So this is also negative square root of 2 over 1. Interesting, right? We found the cosecant of negative 135 and the secant of positive 135 we subtracted, and we see we're getting, it came up as the same number. All right, let's multiply through and see what we get. This will become 2 times the square root of 2 over 3 negative. These two come together to give me a plus square root of 2. This is negative, this is plus. I need to give this one a denominator of 3 so I can add them. Now the radicals match and the denominators match, so I can add negative 2 plus 3 equals positive 1, right? So that comes out to square root of 2 over 3. That is our final answer. Weird, right? This is trig in all its glory. All right, we know enough to be dangerous now, and we're having some fun. Okay, let's try another one. P.S. If you have any clue what I'm talking about, you're doing great. If you totally understand, I don't know, you might need to see a doctor because that's probably not healthy. No, I'm just kidding. But seriously, if you're even hanging on and you're having a glimpse of my reality, you're doing great. It'll all fall into place. Okay, secant of 10 pi